Okay, how do you use graphing technology to solve an equation? So I've got my graphing calculator here. This is an older model, so it might not yours might not look quite like this. Um, so what I'm going to do is I want to find out where. So when you solve an equation, you're basically trying to find out where it crosses the x-axis. So because what you say, when is it equal to 0? So that's what we're trying to do here. Is do I have a pointer here? Let's see, I think I do. So basically, what you're saying is, when is f of x equal to 0? When is this whole equation equal to 0? So what we're going to do is on my graphing calculator, I'm going to press the y equal sign, and then I type in x raised to the third minus 7x, and you can either use the squared button or just do caret 2 again, plus 4 times x, so 4x, plus 30. And then if you're kind of new to graphing calculators, if you do zoom, you've got all these different zoom options. And I always start out with zoom 6. And when that does, let me press the 6. You can either come down to it. You'll graph. And what that does is that sets the window from -10 on the x to +10 on the x, from -10 on the y to +10 on the y. For this equation, we're going to want to change that a little bit because I know it's a cubic equation. So I know the ending behavior looks like this. It goes up, it's increasing, turns, decreasing, turns, back to increasing. And we know the third degree tells us it won't turn back down. So I really would like to find that turning point. But now that I'm saying this, I'm only looking for where it crosses the x-axis. I don't really care about the turning point. So I don't need to adjust that. I'm looking for that place. I want to find that number. I want to find that number and that number, and typically we only care about the x because we know y equals 0 there. So there's a couple of ways to do it. You can hit trace, and then you can type in, I don't know, it looks like not quite -2, so I'm going to type in -2. That'll get me there. See how y is down at -14? We can't see it on the screen, but I can hit my right arrow and I might be able to start seeing it. So negative, and then see how it's jumping around. My screen resolution isn't quite that good. So, but I do see that it's like around -1.7. So another thing we can do is press zoom and then do a zoom 4, which is zoom decimal. Well, maybe before I do that, let's do a zoom 6. You see when I hit trace, how I get, let it finish graphing. When I hit trace, you see how I get all these crazy decimal places? Okay, with that, and how when I was trying to do this, where are we here? So each pixel, the way the calculator is graphing, each pixel on the screen doesn't have enough resolution. So this zoom decimal gives me a little bit better. That snaps it to -4.1 to +4.1, or maybe it's 1, 2, 3, 4. Maybe it's not quite that. But what happens is if I hit trace now, you see how every pixel is worth a tenth of a decimal point now, and you get a little bit better viewpoint. And this works. Sometimes it works really well. It's not working well again. So something to try. So a lot of people like to do this. You see how over the trace button there's that calc, that blue calc? If I do second calc, it gives me some options of what to calculate. And I'm looking for zeros. So I'm going to type a 2. We'll come down to it. And then it's asking, what's my left bound? So I want to make sure I'm below, well, not so much below, but I'm to the left of the 0 that I want. And you can press enter. And then you just hit your right arrow. And to make sure you're to the right of it, hit enter, and then you can guess. Sometimes if there's more than one, you can change it. You can just hit enter, and it should jump to it. So there's my first 0. It's a decimal approximation, which is good enough. That's what they're at. So that's the first place that's crossing the x-axis. Now, see how when I did my zoom 4, I kind of lost one of them. I can still find this one. And the other thing you can do for the 0, let's try this to find this 0. So I'm going to do second calc 0, and then do you see I couldn't use my left right arrow to get there, but see how I know it's between +3 and +4? since it's already in that kind of trace mode, I can just type in 3. And that way it moved to 3. And then I know the other end of it, the right end of it, it crosses between 3 and 4. So my right bound will be 4. And then I'm just going to hit enter. I don't need to get too accurate for my guess. That's my second 0. To get my third 0, I'm going to have to change my window. So I'm going to go back to, window, zoom 6. And let's find that other one. So it looks to me, it could be about 6, just out of curiosity. I'm going to hit trace. I'm going to type 6. And no, not even close. 1, 2, 3, 4. So it's between 4 and 6, I'm guessing. So I'm going to use my calc feature, second calc 0. Their left end is 4. 1, 2, 3, 4. My right end, I'm guessing, is 6. I don't know. We'll find out if it gives me an error. I guess enter. Oh, so it was 5. I guess if I had zoomed in, I might have seen that. So those are the 3 zeros for that. So that's using your graphing calculator. If you're a high school dual enrollment student and you're going to be doing AP Calculus next year, you want to learn to master this. For everybody else, and I mean, as far as a learning tool, that's okay. There's this app, there's this graphing calculator app called Desmos.com. If you have never been there, I encourage you to go check it out. And let's see, let me find my book. What you can do with that in this space here, just type in your equation. So let's say I'm going to do x raised to the third. There's a keypad too you can use that down here. Sometimes we got to use that. And then negative 7x raised to the second plus 4x plus 30. I'm going to hit graph. And note I didn't even have to put a y equals. You can, it's not wrong. And then what's nice about Desmos is you can zoom in, zoom out. And then if you just click on one of those zeros, see how it shows up? Even better than that second calc thing. So that's nice. It'll even show you the turning points. So if you talk about concave up, concave down, if you remember that from chapter 1, we could find our local maximums, local minimums. Okay, but that's not what this problem's asking. So I encourage you to check out Desmos. If you're going to use a calculator, you can too. So hopefully that helps you answer those kind of questions.